Okay, this is a continuation of the types of chemical reactions. So again, go to page 5 in your packet. The last one is called combustion. And combustion is just what it sounds like. It's going to release a lot of heat and light. And that heat and light is coming from usually some type of fire. Some type of inferno. And poor SpongeBob up there, he can't quite get that blown out. Okay, so combustion is a hydrocarbon, and a hydrocarbon is exactly what you think it is. It's hydrogen and carbon, and it can be any amount, okay? And this is going to react with oxygen. So remember that oxygen is a diatomic, so it's going to be O2, and it's going to form carbon dioxide, which is CO2, and water, which is H2O. So this is always the basic form of a combustion reaction. So they're going to expect you to know that anytime you see a hydrocarbon, it's going to be plus oxygen on the reactant side and then carbon dioxide and water on the product side. And hydrocarbons are going to be written with the carbon first. So like, for example, CH4 is a hydrocarbon, C2H6 is a hydrocarbon, C2H2 is a hydrocarbon. So again, it can be any amount. It could be C100, H3000, and that would still be a hydrocarbon, and you would still have the presence of oxygen and the CO2 and water as your product. Okay, so that's just explaining a hydrocarbon. Okay, here's what your formula looks like. So again, the X just means it can be any amount of carbon and any amount of hydrogen. You're always going to have oxygen, carbon dioxide, and water. Okay, always. So in a question, they could just give you the hydrocarbon and they would expect you to know all of this. Okay, so make sure you know all of that. All right, so the general equation is this guy. So go ahead and write down that general equation. And then here's just a lovely visual for you. Iota is acting as our hydrocarbon plus oxygen. And then we have a lot of energy that occurs, which is why we have the little light, the little sword there. And then we get CO2 and water as our product. Okay, here are some examples. This right here is specifically called methane. This is the gas that we use to heat our house. Okay, it's also the gas that comes out when cows flatulate. And again, you're noticing you have the oxygen on the reactant side and then the carbon dioxide and water on the product side. Okay, another example is C3H8, another example of a hydrocarbon. This is specifically called propane, and again, plus oxygen. Oopsie. And your products are going to be that CO2 and that water. Okay, and you'll get heat and sun and light, not sunlight, but heat and light that comes off that reaction. Okay, here's a couple videos for you, just some fun little things for you to watch that are examples of combustion. Here's a little video. Okay, so it says write a balanced equation for the combustion of C2H4. So automatically when you see this, you're going to think, oh, C and H, hydrocarbon. So that's what your equation is going to look like. And then you would go ahead and you would balance that. And when you balance it, you're going to get C2H4 plus 3O2, arrow 2H2O plus 2CO3. Let's do another example. So let me go back here and just trying to find another example. I'm just going to add a new slide. Okay, let's do this. So this is the question I was referring to on one of your homework assignments. It was question, let me find it, question 8 on page 10. And I said you'll learn more about this. This is what I'm talking about. Question 8, page 10. Okay, let's do, let's do C7. This is called heptane, H16. So let's say you see this, and that's all you see. You're going to think, oh, hydrocarbon. So you're going to add oxygen to it, and because it's a diatomic, you're going to make it an O2, and automatically your products are CO2 and water. Okay, and then from here, you're just going to balance it. So right here, we have 7 carbons. So right here, you're going to put 7 in front of the carbon. Then you've got 16 hydrogens. Here you have 2. So 2 times what makes 16? Oh, that's 8. Then your total amount of oxygen, it's going to be 2 on this reactant side. On the product side, you're going to do 7 times 2, which is 14. Plus 8, which equals 22. So 2 times what is going to equal 22? Well, that's 11. Okay, so they're kind of fun to balance. You'll kind of start to notice some higher numbers. Okay, let's do another example. Let's say that we do C9. So let's do C9H2. Just kidding, let's not do that one. I'm trying to give you a better example. Let's do C4. Let's do C4H10. This is called butane. This is the gas that's in lighters. And you're going to see that, and you're going to say, oh, plus oxygen. And then your products, again, are going to be CO2 and water. It doesn't matter, I can put water first or CO2 first, as long as they're both on that product side. Okay, let's go ahead and balance this one. So carbon, we have 4. Over here, we have 1. So we're going to go ahead and put a 4 in the front. Hydrogen has 10. Here it has 2. So 2 times what makes 10? That would be 5. And then we have 2 oxygens on that reactant side. And on the product side, we have 4 times 2, which is 8. Plus, that's going to distribute, and that's going to be 5. So we have 13. Okay, there is a trick when you balance this. Okay, are you all listening? If you're not listening, all listen. Okay, eyes and ears. So, when you have a combustion reaction and you have an odd number of oxygen on the product side, like we do in this case, odd number, what you're going to do is you're going to stick that odd number in front of the oxygen. Okay, let's make that a darker color. We're going to stick that odd number in front of the oxygen. Now notice it's 13 times 2, so this now becomes 26 oxygen atoms. So because it's times 2, we're doubling it. So what we have to do is double, okay, again, I'm going to repeat, double the coefficients of the other reactants. So right here, this is going to go from a 1 to a 2. This is going from, oh, the 13 just stays here, my apologies, the other reactants. A 4 to an 8, and a 5 to a 10. Okay, so now let's double check really quickly and make sure this looks good. Okay, I'm going to rewrite that because that looks sad. Plus, that would have been 13. Okay, so right here, 2 times 4 is 8. Right here, you've got 8 carbons. 2 times 10 is 20. 10 times 2 is 20. And then our oxygen, we've got 13 times 2 is 26. On this side, we've got 8 times 2, so we've got 16 plus, that distributes 10 equals 26. Okay, so again, that rule is this. If you balance a combustion reaction and the oxygen has an odd number, and remember you always balance oxygen last, if the oxygen has an odd number on the product side, you take that odd number and you put it in front of the oxygen on the reactant side. Then you double the 3 other coefficients. So you're going to double the coefficient on the hydrocarbon, the coefficient on the CO2, and the coefficient on the water. You're going to double those. Okay? I hope that helps, and enjoy.